Okay, this is the first practice question from chapter 3, multivariate probability distribution. So you're given a bivariate joint probability distribution and you're asked to find the marginal distribution of x and y. So the first question, let's find the marginal distribution of x first. Marginal distribution of x is a table with the possible values of x, 0, 1, 2, with the corresponding probability PMF. Probability that x is equal to 0 is the first column total, 0.38. Probability that x is equal to 1 is the second column total, which is 0.2. And the probability that x is equal to 2 is the third column total, which is 0.42. And that is the marginal distribution of x. Then the marginal distribution of y. The possible values that y can take are 0, 1, 2, and the corresponding probability mass function will be the row total 0.3, 0.3, 0.4. So that's the answer to the first question, finding the marginal distribution of x and y. The second question is to find the expected values and variance of x and y. Expected value of x is the value of x times the corresponding probability. So 0 times 0.38, 1 times 0.2, plus 2 times 0.42 to get 1.04. And then to find the variance of x, we need e of x squared, which is the value of x squared times the probability. So we have here 1 squared times 0.2, 2 squared times 0.42. So expected value of x squared is 1.88. And therefore the variance of x is expected value of x squared minus expected value of x, the whole squared. 1.88 minus 1.04 squared, you get 0.7984. And now the variance of mean and variance of x. Expected value of y is the value of y times the corresponding probability. 0 times 0.3, 1 times 0.3, 2 times 0.4 is 1.1. Okay, 1.1. That is mean of y. To find the variance, we need e of y squared. 0 squared times 0.3 plus 1 squared 0.3, 2 squared 0.3. Sorry, 2 squared times 0.4. So we get 1.9. Therefore, variance of x is, variance of y is e of y squared minus e of y the whole squared. 1.9 minus 1.1 squared, which is 0.69. So this is the mean of x, this is the variance of x, and here we have mean of y, and this is variance of y. Okay, that's the answer to the second question. The third question, are the random variables x and y independent? The two random variables will be independent if for all combinations of x and y, the joint probability is equal to the product of the marginal probabilities. So, for example, if you take probability of x is equal to 0 intersection y is equal to 0, that is the joint probability, you get 0.1. You have 0.1, but when you multiply the probability of x is equal to 0 by probability of y is equal to 0, it is 0.38 times 0.3, which is not equal to 0.10. So if even for one combination of x and y, if the joint probability is not equal to the product of the marginal probabilities, you can say that x and y are not independent. Okay. The next question is to find the covariance. So I'm going to use this table to find the covariance. To find covariance, we need expected value of x, y. Okay, because the formula to find the covariance is covariance xy is equal to expected value of xy minus e of x, we already found that, times e of y, we have found it. Now we need to find the expected value of xy. So e of xy is equal to, for each combination of x and y, it is the value of x times the value of y times the probability. X times y times the joint probability pxy. And now you can see that if you multiply x by y by joint probability, all these values, when you use it for multiplying x and y and then the probability, it's going to be 0. So there is no non-zero contribution from the first column. Because x is 0, there is no non-zero contribution from the first row because y is 0. So I'm going to consider only these 4 cells. So for those 4 cells, the value of x times the value of y times the probability. Okay, so what I've written now here is the value of x is 1, the value of y is 1, the joint probability is 0.06, and then moving to the next one, the value of x is 2, the value of y is 1, the joint probability is 0.16. And moving to the next cell, value of x is 1, value of y is 2, the joint probability is 0.08. And the last one, the value of x is 2, the value of y is 2, the joint probability is 0.12. Therefore, E of xy is 1.02. Therefore, covariance of xy is equal to 1.02 minus expected value of x that we found before, 1.04, times expected value of y is 1.1. So the covariance is minus 0.124. And this is how you find the covariance of x and y. And